Hello there, Mr. Sutton here, bringing you the AB Calculus 5-2 Part 1 homework solutions on antiderivatives Part 2, simplifying before taking the antiderivative. For this problem, at first glance we have a product inside this integral, but we can actually distribute this and then take the antiderivative. So this is going to be 6x to the 5th plus 20x cubed. And then going step by step here, term by term with the reverse power rule, this bumps up to a 6. 6 over 6 is 1, so we've got 1x to the 6th power. And then here, this is going to bump up to the 4th power. 20 over 4 is going to give us 5x to the 4th plus c. For number 2, we've got 1 over the square root of this crazy expression that we want to antidifferentiate. Now, the key on this one is noticing that this expression is actually one of those perfect square trinomials. You can factor this into x plus 7 quantities squared, which, if you square root it, is just x plus 7. Since we have 1 over x plus 7, that fits the general rule of ln of whatever we had down here. So we can write this as ln of absolute value of x plus 7 plus c, and then we do have a linear function in here, but we just have a coefficient on the x of 1. So this is just plain old ln of x plus 7 plus c. For number 3, this looks kind of intimidating, square root of all this stuff. The key is recognizing that the stuff inside here is really just 6x squared minus 1, the whole thing squared. If you don't believe me, you can FOIL this back out. I got this from noticing that I had these two perfect squares, and then if I multiply 6x squared and negative 1 together and double it, I do indeed get this middle term, so it does check out. Square root of all this stuff now is just 6x squared minus 1. And for this one, I can just go through term by term with my reverse power rule. So I'm bumping the exponent up to 3, dividing by 3, so I have 2x to the 3rd minus 1x plus c. For this problem, the key is that we are able to simplify the integrand here. So we are going to factor this and see if we can cancel out that x minus 3. Up here, we need two things that multiply to negative 15 and add up to 2. That would be x minus 3 and x plus 5. So canceling out those x minus 3's, we've got the antiderivative of x plus 5. And then just going term by term with the reverse power rule, this is going to be, let's see, that bumps up to the 2nd power. So we have 1/2 x squared plus 5x plus c. For number 5, we have a whole bunch of trig functions in a fraction. So at this point, we're thinking maybe we can turn this into something else using our identities. We have a sine over cosine, which is tangent, and then we have a invisible 1 over cosine, which is secant. So we can really rewrite this as negative 3 secant tangent of x. And then secant tan, that's the function whose antiderivative is just secant, because the derivative of secant is secant tan. So we can just write this as negative 3 secant of x plus c. For this problem, we're trying to take the antiderivative of this square root monstrosity here. Now the key on this one, if you look closely, we've got a perfect square sandwich inside here. This can actually be factored into 8x plus 2 quantities squared. And if you don't believe me, we could just multiply it back out. So that would be 64x squared, multiply these and double it for that middle term of 32x, and then square the last thing for 4. Well, the square root of something squared is whatever was being squared. So when all is said and done, we're just taking the antiderivative of 8x plus 2. And then going term by term with my reverse power rule, this bumps up to x squared. Divide by 2, we have 4x squared plus 2x plus c. For this problem, we want the antiderivative of negative 3 over cosecant of x dx. Now, this one, you could take the reciprocal of cosecant, which is sine, and move that upstairs. So we can rewrite this with trig identities as negative 3 sine of x dx. And now the antiderivative of this, well, the antiderivative of sine is going to be negative cosine. So this is going to be a negative negative. That cancels out. So we're going to have positive 3 cosine x plus c. On this problem, the stuff inside the square root here can actually be factored. So this is x minus 4 quantity squared inside here. The square root of that is just going to be x minus 4. And then this is actually essentially your ln rule here. So this is going to be ln of absolute value of x minus 4. And there's no derivative other than 1 for this thing, so we're all set with the plus c. For this problem, the key on this one is that we can turn 1 over secant of x into cosine of x, so negative cosine of x. And then the antiderivative of that is just going to be negative sine of x plus c. On this problem, we need to simplify these trig functions a little bit first before we can really take this antiderivative. So I've got cosine over sine times 1 over sine, essentially. That's going to be cotan times cosecant of x with a negative 3 out in front. And then the antiderivative of this is just going to be a positive 3 cosecant, because the negative here is what we get if we take the derivative of 3 cosecant. And don't forget the plus c. On this problem, we're trying to take the antiderivative of a product. So in this case, it looks like we can actually simplify this to be just a regular polynomial-ish looking thing. So let's multiply 5x by everything. This is going to be 5x times x to the 1/2. So this is going to be 5x to the 3/2 minus 5x to the 3rd. And now we're just going to go term to term and use our reverse power rule. For this first one, we can bump the exponent up to a 5/2, and then we have to multiply by the reciprocal of 2/5. 5 times 2/5 is just 2, so we have 2x to the 5/2. Next, this bumps up to a 4. Dividing by 4, we have negative 5/4 x to the 4. And of course, we have the plus c, which gives us answer choice C. This problem here is kind of tricky if you don't know what they're expecting. I mean, you can't even factor the stuff down here. So even if you knew how to do integration by partial fractions, it wouldn't help you here. So what else is there? Looking at the answer choices, there's all sorts of things they're throwing at us. There's the ln here, which is probably not going to work. If you take the derivative of this, you'll very quickly see you don't end up with this because we have a tail of 2x plus 4. This one down here, I mean, it looks like they just did 1 over and then did the reverse power rule, which probably isn't right either. And then that leaves us with these other two options, which are kind of weird. Arctan and arcsine. So one way you could do this problem, since it is multiple choice, is to just actually take the derivative of these and see if either of them give you this. And you'll actually see that the derivative of arctan does end up being this. However, if you wanted to kind of start from scratch and just take the problem on its own terms, what you could do here is you could split this up into x squared plus 4x plus 4 plus 1. Which is kind of weird. Not many people are going to think to do this, but you can do it because now what we've got is a perfect square. This is really x plus 2 quantity squared plus a 1. If you have, in general, 1 over something squared plus 1, that's an arctan kind of situation. So in this case, we can just write this now as arctan of whatever is inside of here plus c. And the only thing we have to be careful about is if the stuff inside of here does not have a derivative of 1. But since it does, we don't have to divide by any linear tails or anything like that. So that's going to end up giving us answer choice A. On this problem, we're trying to take the antiderivative of this squared expression inside here. So I'm going to start by expanding this expression, just basically multiplying x squared plus 1 by itself. And I'll use my little a squared plus 2ab plus b squared shortcut to do that. So squaring the first thing, I get x to the 4th. Multiplying the two terms and doubling them, I get 2x squared for my middle term. And then squaring the last thing, I get 1 for that last term. Or you could FOIL it out and combine like terms. Anywho, going through now and using my reverse power rule on each term, first exponent bumps up to a 5, so we have 1/5 x to the 5th. Next exponent bumps up to a 3, so that's going to be 2/3 x to the 3rd. And then this 1 becomes a plus x plus a c, because I always have the plus c. That's going to be equivalent to answer choice E. They just wrote the fractions a little differently. On this problem, we want the antiderivative of 1 over x squared minus 2x plus 2. Now this one's a little bit tricky. You'll see the denominator is not factorable at all. they did give you a hint up here. They said rewrite the denominator as something squared plus 1. And the reason that would be nice to do is because something squared plus 1, that's the format of the derivative of arctan. So if we can rewrite the denominator like that, we might be able to go backwards and incorporate arctan with our answer. Now there is actually only one answer that has arctan in it, so that's probably going to be our answer, but let's just go ahead and do the algebra here. So I'm going to write this as x squared minus 2x plus 1 plus 1, because I can now factor the stuff that I took away from the plus 1 there, the stuff inside the parentheses, to be x minus 1 squared. Now if I take the antiderivative of this is going to be arctan of x minus 1. And I do have more than just x inside there, but because its derivative is just 1 and it's linear, I don't have to worry about anything there. So I can just write this as arctan of x minus 1 plus c, which gives me answer choice E. And in case you were wondering what happened to the plus c that we always get with our antiderivatives, notice that they said an antiderivative. So this is an antiderivative. It's just got a c value that they've inserted there of 0. For number 15, this antiderivative becomes a little bit easier if we expand this out. So this will be, let's see, x to the 6th plus 2x to the 3rd plus 1. And then anti-differentiating term by term, this bumps up to a 7, so we have 1/7 x to the 7th. Plus, well, this bumps up to a 4. Dividing by that, we have 1/2 x to the 4th plus x plus a c at the end. So that's going to be answer choice B. On this problem, I've got a fraction that I need to take the antiderivative of. And looking at my fractions, since I only have one term in the denominator, I can actually divide everything by x squared and then use my reverse power rule. So x cubed over x squared is x. 5 over x squared, I'm just going to rewrite that as 5x to the negative 2. And now using my reverse power rule, this is going to become x squared over 2. And then this next one, this bumps up to a negative 1. Dividing by that, we've got negative 5x to the negative 1. And then all of that plus c. So that's going to be answer choice, let's see here, C.